Welcome, friends, to this series of learning containers and Kubernetes. So, in the last lecture, we got introduced with Red Hat Openshift, and we learned about various features about Red Hat Openshift, and we came to know how it is different from the normal Kubernetes vanilla clusters and what are the benefits we do have on Red Hat OpenShift and why recent trends in the industry actually leans towards this OpenShift platform. So in this particular lecture, we will actually deploy one of our favorite applications in Docker Hub to Red Hat OpenShift cluster. So let's get started. So friends, if you Google OpenShift Dev Sandbox, you will get this developer sandbox for Red Hat OpenShift link. And if you click the very first link over there, you will be landed up in this particular page. So now, Red Hat OpenShift is actually providing you a developer sandbox for your free learning. And I would recommend each of you to go through this site and have your sandbox ready, and you will be 30 days no cost access to a shared cluster on OpenShift. So this exciting offer we will get without spending a penny. So it's great, really great opportunity for you to have some learning on this OpenShift platform through the sandbox environment. Now, first, you need to create an account in OpenShift, and we have already created one account with our email address. And once you are done with that, you just start your sandbox for free. And if you click that link, you will be asked to create one cluster for your 30-day trial period. So Red Hat is actually offering you a free Red Hat OpenShift platform. Apart from that, you can get the access of Dev Spaces, which is a collaborative Kubernetes native solutions for rapid application development that delivers the consistent developer environments on Red Hat OpenShift to allow anyone with a browser to contribute code in under 2 minutes. And this is the time when we are interested on Red Hat OpenShift. This is a cloud native application platform with everything you need to manage your development lifecycle securely, including standardized workflows, support for multiple environments, continuous integration, and release management. Apart from that, Red Hat is offering the OpenShift AI. So it basically gives the data scientists and developers a powerful AI and machine learning platform for building the AI-enabled applications. So if you launch this Red Hat OpenShift, you'll be landed to a dedicated cluster for your OpenShift platform. And there you will be having two roles. One is for administrator, other was for developer. So you can literally access a vast majority of things in OpenShift, and this dedicated environment will be offered for you for 30 days to create any sample application in a development environment. You can import the code from Git, and you can enjoy the CI/CD platform over here. You can build one container image and just get that image from your favorite repository, and you can run or spin up the application in OpenShift platform. So in this today's tutorial, we will actually use our Docker Hub image. So if we go ahead and check our Docker Hub image, we can see we are having one My App application in our Docker Hub repository. In the earlier couple of lectures, we saw how we can build this learning light My App Docker image, and we push this particular image in our public repository, and we are having two versions of it. And this time we are going to pull this version 1.1 in our Openshift cluster, and we will see how we can easily build this application. So what we will do, we will just move to this developer platform, and we will notice in the topology center what exactly we do have right now. So one workshop container is provided by Openshift for us. We will just ignore this one, and we will continue adding the new application in this environment. So here you can see one shell environment is provided to us. So this OpenShift command line terminal, we will actually open in a new tab, and we will see how we can easily interact with this CLI to build our application and run the application in OpenShift platform. So right now, if you see OC is the command, this is just like the kubectl that we saw in earlier lectures. It's exactly same, but in this OpenShift platform, we will say OC instead of kubectl, and then we can literally use the same kinds of commands like get pods. We will see what are the pods are currently running. Also, we can see as OC get all, what are the all things we have in our entire environment. So we can see a couple of pods and services and deployments are running inside our OpenShift cluster. And as you can understand, these all are provided by OpenShift by default. So we are not going to touch anything, but we will actually use our Docker Hub repository, and we will build our My App application in our OpenShift platform. Apart from this My App, this particular My App will actually need a MySQL database, and we will actually create a MySQL database. Also, we will pull the MySQL database from our Docker Hub repository, or even we can use the quay.io. We can pull the MySQL container image from any of these repositories, and we will deploy them in OpenShift platform. So let's try to pull this MySQL database from our Kubernetes native container repository. And this is what the command is, OC new app, and then we are going to use the Docker image that we are going to pull right now, and we are going to keep the name as MySQL RHEL7, and we are going to say the root password of this particular MySQL server will be root 123. If we do so, we can see our container, our MySQL database is actually deployed in our OpenShift platform. And this is the container. You can see this is the pod you can see that is actually running right now inside our OpenShift platform. So here it is saying that we can check OC status, and definitely we can see our service of MySQL server is actually running. and this is actually running from this particular internal IP address. Even we can see OC get SVC minus O wide. We can see our MySQL cluster IP is actually 172.233.177, which is nothing but this one. And it is running from port number 3306, which is the default port of MySQL server. So we will actually note this cluster IP, and we will right now going to deploy our my app application over here. So this is the command we are going to run right now. So this exactly the same command like how we deployed the MySQL server, but this time we are going to say OC new app, and we are going to provide our image instead of taking it from Openshift's default container. We are specifying please pull the image from docker.io, and we are going to say learning light slash my app version 1.1, and we're going to name this particular service as my app. And here we are going to provide the environment variables which you can check in our Docker Hub repository. We have a couple of environment variables to provide so that this app can interact with the database. So DB user is actually root, and MySQL root password. This is the password that we have given when we ran this MySQL database, and this is root 123. So this is what we have mentioned over there. Environment MySQL root password is root 123. Now the next one is DB host. Now instead of keeping these host IP, we are going to provide the host IP, which is actually right now it's shown in our screen, which is 172.30.233.177. And we're going to say DB port is 3306. So basically, we have provided all the environment variables that are needed to run for this my app Docker container. So if we run this command, you can see our application is going to be running. Now you can see our my app container is just started, and you can see there is one port has been started to run. Now this particular deployment needs to be exposed to the external world so that we can actually connect to this application from external world. So for that, we need to expose the service to external world. And this is just exactly the same OC expose service, but this time you can notice that our particular learning light slash my app application is actually running from port number 5000. So we need to specify that our service should be exposed at 5000 port. So we can see our service is exposed, and we can check the service like OC get service minus O wide, and we can see our service is actually ready, and we can see this is being served from 5000 port. Now, if we see that there is a little arrow has been marked over there because the service has been exposed to the external world. If we click this one, we can see our Streamlit application has started to run, and this is also going to connect to this MySQL database server, which we actually connected with this my app application by providing the cluster IP of this particular MySQL service. So we can literally put one item, which is called, maybe we can say Red Hat, and we can specify the second item as Openshift and insert the item, and we can see the items are listed over here. Now, the app is running fantastically. Now, let us scale this particular uh, pod. Right now, in this particular cluster, this My app is running with one pod. And if we just click this particular arrow, up arrow, you can see this pod will be scaled to two pods. So if you go ahead and check, and let me clear the screen first. And if we check OC get pods minus O wide, you can see our My app pods are running, and these pods, there are two pods for My app service. Now, for this particular deployment, you can see that they are running from different nodes. So one is running from 61, other one is running from 280, 248, and there is another node you can see which is not being used by our My app, but the MySQL is actually running from different nodes. So there are number of nodes are there inside this particular cluster, and we can scale our deployment at any value by clicking this up arrow or down arrow. Okay, we can scale this particular deployment from the command line prompt as well. Just specify that OC scale replica, and we can specify any kind of numbers like number 4, and we can say deployment My app, and your application My app actually scaled to 4 pods. We can see over here as well instantly these 4 pods are running at this moment. And if we refresh this particular page, it is being solved by any of those 4 pods. And all these pods can communicate with the database without having any issue. Now, until this point, everything is going good. But for this particular MySQL deployment, right now we are having one pod running in the system. Now, if we scale down to 0, what will happen? Okay, so if we scale down to 0, so right now there is no MySQL database server is actually existing in this cluster, and the My app cannot connect to this MySQL server anymore. So if we go our application and refresh this page, we can see this MySQL server is no longer being served. So what we will do, we can easily scale up. So the point is that at any moment the pod can die, and if the pod can die, the Kubernetes, if we say this OpenShift cluster to run the minimum number of replicas like 1 or 2, so OpenShift cluster will be liable to run those number of replicas all the time. Doesn't matter whether it gets scaled down or whether it gets dies, it will automatically spin up the new content. So if you go ahead and check this page and refresh the page, we can see our application right now can connect to this database. But the problem is that we are going to lose our data because the last time we pushed a couple of data in this particular database, but when we click the show item, it is saying the database test DB is unknown because it created the test DB, inserted the data into this test DB, but when we scaled this particular MySQL pod to 0, the data inside the container just gone. That means whatever the data we had in this particular MySQL database, that got vanished. But that should not be a good scenario, right? You are running your production application in the containers, and if the data is done, then how you are going to ensuring your client that OpenShift environment can preserve your data without losing them? So there the concept of persistent volume comes to the picture. So we need to create one persistent volume claim. So this is a permanent SSD inside this cluster. And this is basically going to be mounted in a shared mode. And this is a persistent volume that we need to create. So we can either create with form, and this is what I'm going to say, my volume. And then I'm going to specify some size. Now this particular storage will be allocated in the cluster, and any pods, those are actually have the access on this particular persistent volume claim, they can attach this particular disk, and it can attach this particular disk as a file system and can use that file system to read and write data. So this particular persistent volume claim we are creating for our MySQL database. So right now I have created this one and it's in pending status. So once we actually attach this particular volume to our MySQL database, this particular state will be in bound. So let us go to this MySQL deployment, and we are going to edit the deployment. And if we edit the deployment, our YAML deployment file will be opened. Now here, we need to do something. We need to edit this particular template. Let's edit this thing. So first and foremost thing, we will use our volumes over here, and we are going to now we have specified the volume that we have created inside this YAML file, and we're going to say this name of this volume over here as MySQL storage, and the claim name is my volume. Now we need to mount this volume inside the container, and we can specify the mount point inside this container as volume mounts. Okay, so now we need to see where our containers over there. So here after the ports, maybe we can specify this mount volume. All right, we are going to mount this MySQL storage as world lead MySQL. Now this world lead MySQL is the place where actually MySQL container stores this data. So once we do that, we're going to save this deployment, and this particular deployment is now going to be scaled to 0, and then it will scale to 1 to just make this deployment ready, and the new container will be running. And that time, this container will have the disk which we actually attached from this persistent volume claim to this particular deployment. Now, once this is done, we can actually run our application without worrying about the data loss. So if we refresh this particular page, we can see the application again can continue with connecting with the database. Now, this time we can say Openshift, insert the item, and we can say the second item as Red Hat, and and maybe we can say third item as learning light, and we can see the items are actually inserted. Now, we will do the same exercise right now. We will scale this particular deployment, which is MySQL RHEL7 to actually scale down to 0. If we scale down to 0, we can see right now it's scaled down to 0 and our application is not able to connect to the database. If we refresh this one, we can see it's not being connected. Now we can again scale down, scale it up to 1 port. And once we do so, we can see this is actually right now being scaled from 0 to 1. But this time, as it is having this persistent volume claim, we can see the data should be there inside the database. And if we click this show item, we can see the data is preserved. So thank you for watching this video, friends. So in this particular lecture, we saw how we can run the application in Openshift platform and how we can actually create the persistent volume claim to store the data, and we can forget about the data loss inside our Openshift cluster. So thank you for watching this video once again. And in the upcoming lecture, we will see how we can play around with different things in Openshift in our dev sandbox. Also, in the upcoming lectures, we will use other managed services like GKE, which is Google Kubernetes Engine, and also we will play around with AWS AKS, which is AWS Elastic Kubernetes Service. And also we will play around with Azure's Kubernetes Service and other Kubernetes platforms in different service providers. Those are actually a managed Kubernetes. Also, we will continue our lecture on our on-premises Kubernetes system that we actually installed in GCP and AWS environment, how we can monitor those environments with the help of different monitoring tools like Prometheus and Grafana. So let's continue our journey and let's enjoy the complete playlist of containers and Kubernetes. Thank you, friends. Have a nice day. See you in the next lecture. Till then, goodbye. Be safe.